Hi there, everyone. So what we're going to be talking about today is the sum and difference of two cubes. So before we go into deriving this formula, okay, so this might look kind of scary. Before we go into deriving this, I actually want to go over with you guys how to do a little bit of long division first before we delve into this long division. All right, so let's skip this page for right now. We're going to come back to it, and I want us to look onto the next page. All right, so this is page 36. We're going to do some long division practice, and then we're going to go into that long derivation, which I know you guys can handle. Okay, so for our first problem, this is like probably asking, like, why are you asking me this? This one's so simple. Well, I want us to recall how you guys do long division by hand. That way you can get into the routine of how to do it by hand, so that way when we do it on the previous page, it comes more naturally. So we first see, well, does 6 go into 4? Does 6 go into 4? It doesn't, so that's a 0. Okay. Does 6 go into 48? It does. It goes into 48 8 times. So we're going to subtract out 48 because 6 times 8 is 48. Okay. Does 6 go into 0? No, it goes into 0 0 times. So we're left with 0 as our remainder. So 6 goes into 48 80 times. Okay, let's take a look now at question 2 together. All right, so again, so we just did 1, we'll do 2 together. All right, well, how many times does 5 go into 9? So we look at the first number, it goes into it once, right? Because this can only go into it once because we'll subtract out the 5. So 9 minus 5 is 4. We bring down the 6. Just make sure you're paying attention to the steps and like the process behind long division by hand. Okay, well, 5 goes into 46 9 times, because 9 times 5 is 45. So we subtract out that difference. We get 1, bring down the 0, and it continues. 5 goes into 10 twice. We have no remainder. So the long division of 5 going into 960 is 192. Okay, let's start to make it just a little bit more difficult now. Let's take a look at question 3. So c plus 5 going into c squared plus 5c. Okay, well, guys, it's the same process. How many times does c go into c squared? C goes into c squared c times, right? C times c is c squared. So that checks out. Okay. All right, well, let's see what's next now. So we're going to multiply back. C times c is c squared. And then we're subtracting out, so this whole thing gets subtracted out. C times 5 is 5c, right? Because we always subtracted out whatever we were multiplying it by. So that's why this subtraction is here. You really are just distributing that negative, so I'll be left with nothing. So the answer here is just C. All right, you guys can give question 4 a try. Let's do question 5 together. Okay, so now we have, again, a binomial being divided into a trinomial. So we want to see, how many times does x go into x squared? X goes into x squared x times. So I'm going to subtract out. We remultiply back in. X times x is x squared. X times 3 is 3x. Okay, sorry if that's a little sloppy. Okay, well, we're going to distribute that negative, so x squared minus x squared is 0. Negative 2x minus 3x is negative 5x. We always bring down that other term, just how we did in the very top of the page, modeling what long division looks like with just like regular numbers, maybe no variables. Okay, well, if this is now what I'm left with, now we want to see, how many times does x go into negative 5x? X times what is negative 5x? We're missing a negative 5. So now we're going to multiply that negative 5 back in to each term. So let's do that. Okay, so we're going to subtract out always when we're dividing out, we subtract out the remaining. So negative 5 times x is negative 5x, and negative 5 times positive 3 is negative 15. When I subtract this out, this becomes positive, and we're left with 0. So there's my final answer of x minus 5. Okay? I want you guys to try question 6. In the end, for question 6, you should end up getting x minus 3. That's how you know you did it right. And then for 4, you should end up getting 8q up here up top. That's how you know you did it right. Okay, moving on. Let's take a look at question 7 together. Okay, so again, just more practice with this, and then we're going to go back to the other page and perform that derivation. So I have x times what? So x times what gets me to x squared? Well, x times x. Then we subtract out our quantity by multiplying back. X times x is x squared. X times 1 is positive x. Subtract it out. I'm left with negative 10x minus 10. Again, same process. Now we want to see x times what gets me to negative 10x. X times negative 10 is negative 10x. So this should be minus 10. And we're going to redistribute back. Negative 10x, and then this will be negative 10 times positive 1 is negative 10. Again, if you want to go the route of like keep, change this to plus, plus, and plus, and you're left with nothing. So there's your final answer. Question 8 is definitely more of a challenge if you want to try it. Hint, hint, make sure you have placeholders for terms that are missing. All right, last one I'll show you guys here is number 9, so that way we can go back to the other page, which I believe was page 35. Yep. So we're going to do number 9 together, and we'll go back to page 35. So, okay, same thing. Now we just have more terms here to divide by. We want to see x times what? So x times what will get me to x cubed? X times what is x cubed? Well, that's x squared. Okay, then we re-multiply back. So we're going to subtract out. X squared times x is x cubed. And then x squared times negative 3 is negative 3x squared. Okay, I just rewrote that a little bit neater. Okay, so now we're just going to distribute. So that's going to go away. And then we'll have negative 3x squared plus 3x squared. Oh, well, that goes away also. So let's bring down then our next set of terms. Plus 3x minus 9. Okay, so let's just rewrite this here. So I'm going to erase the zeros. And we have 3x now minus 9. Because that all went away. Okay, well, x times what will get me 3x? X times positive 3. So I'm going to subtract out, because now we're going to multiply back, so we can erase this. That was x. Okay, 3 times x is 3x, and 3 times negative 3 is negative 9. Distribute, and we're left with 0. So there's my final answer, x squared plus 3. Okay, let's go all the way back now, guys, to that very first question. We're going to talk about the sum and difference of cubes. Okay, so we're going to derive this formula here. We're going to derive this right now. So let's just zoom in, see what we got going on here. So I have a times what? A times what gets me to a cubed? A squared. So let's multiply it back throughout. A times a is a cubed, and a squared times negative b is negative a squared b. These are placeholders. Let me highlight them here for you in pink. These are placeholders because of the terms that we just picked up. I just picked up this term here. Here, I'll color it in black. Just picked up that term. Okay, so what I have highlighted in pink is a placeholder. It helps us with long division. Okay, so we're going to distribute this throughout. So this is just 0, and I have negative times a negative. So this is positive a squared b. Bring down the other placeholder. Okay, so now again, let's go back. So let's see. Now we want to see a times what gets me to a squared b. So a times what gets me to a squared b? Well, we're missing an ab. So this needs to be ab. And we can multiply back. AB times a is a squared b. And ab times negative b is negative ab squared. And we're just going to distribute. We'll see these cancel out. and I'm left with positive AB squared. And as always, we bring down that last term. Okay, now lastly, we want to see A times what gets me to AB squared? A times what gets me to AB squared? Well, I'm just missing a B squared. So we have plus B squared. And we're going to distribute it back. So A times B squared is AB squared. That was the whole point. We want these to cancel. And then B squared times negative B is negative B cubed. This becomes plus plus. And there is our final answer. So we actually just derived, I'll circle it actually here in red. We just derived the formula for the sum and difference of cubes. So the sum and right now we just did this for the difference of cubes. Okay, so that's actually right here. We just derived this formula. Okay, you guys will need to have this memorized. So this is the difference of cubes. Here is the sum of cubes. So we could have done the same thing and just now changing it to A cubed plus B cubed. All right, so write those formulas down somewhere, highlight them, don't forget them. We're going to be using them, right? So if we go all the way over now to page 37, we're going to be using these formulas. All right, so you guys can see here on page 37, I have the formulas written here on the side for you. So let's start off with the first one so we can actually see, what does this look like? Okay, so for the first one, well, I see subtraction in the middle, so I'm thinking difference of cubes. And it's written right now in this format of A cubed minus B cubed. Well, I want to rewrite these in terms of A and B. X cubed is equal to A cubed, so X must equal A. 27 is equal to B cubed. Well, what times what times what will get me to B cubed? That really is 27. 3 times 3 times 3. So B is 3. Guys, really all you're doing is just taking the cubed root of these numbers to figure out what A and B are. Okay, so let's write it out. We have to follow this format. So I have A is equal to X. So I have X minus, here's B, 3, times A squared, so X squared, plus A times B, so plus 3X, and then B squared, 3 squared is 9. And that's it, guys. I just wrote this out using the difference of cubes formula. Okay, let's look at like another problem. Let's do question 3, and we'll do 5 together. Okay, so for question 3 again, I notice now there's addition in the middle, so now we're looking at the sum of cubes. So now we're looking at A cubed plus B cubed. Well, A is going to equal X again, and now what times what times what is 8? And that's 2 times 2 times 2, so B equals 2. Okay, now that I found the values that I can substitute in for, let's apply them to the formula. So following this formula right here, I have X plus 2, because there's A and there's B, times A squared, which is X squared, minus 2 times X, plus 2 squared, which is 4. And that's it. All I'm doing is just applying the formula. All right, well, let's look at question 5. And for question 5, we have 8x cubed minus 2. So again, we have that A cubed minus B cubed. So I'm looking at the difference of cubes. Okay, now this one's a little bit different, but not really. So now we're just trying to see what times what is equal to 8x cubed. Well, we said 2 times 2 times 2. And now we just have an additional x thrown in here. So A is equal to 2x and B is equal to 1. Because 1 cubed is just 1, guys. Okay. All right. And I'm just going to plug into my formula up here. So let's just highlight over that. There's my formula. So I have 2x minus 1 times, I have A squared. Be careful here. It's 2x squared plus 2x times 1 plus B squared. And I'm just going to rewrite this out. I have 2x minus 1 times 4x squared plus 2x plus 1. And there's my final answer. All right, just to give you guys some extra practice, I want you guys to go to page 38 and I'll circle the problems I want you to do. All right, so on page 38, you guys are going to do questions 6, 7, and 10. And the last one I'm going to do with you is number 9. So for number 9, so again, I'm going to zoom in now, but you should be doing 6, 7, and 10 on this page. All right, so for number 9, now we should be looking at, we have a cubed. Again, I'm just going to write the formula because I see the subtraction in the middle. So I have a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Okay, so that's the formula. But I notice 2 is not a perfect cube. And neither is 128. That's also not a perfect cube. Guys, do you see it? What can you do first? Factor out the GCF. Take out the 2. So when I take out the 2, I'm left with x cubed minus 64y cubed. And now I have perfect cubes. So really, you can think about that as a 1 out front. That's 1 cubed. And the cubed root of 64 is 4, because 4 times 4 times 4 is 64. So I have it now. Okay, so let's write out our a values. So ignore the 2 on the side. We're going to write our a value here as x, and our b value here is 4y. So now we're just going to plug in. Leave that 2 out front. Don't worry about it for right now. Let's just deal with this. So I have x. Let's rewrite that. X cubed minus, really this is 4y cubed, is equal to, so let's fill in. We have x minus 4y times x squared plus 4xy plus 4y squared, which is 16. I'm just running out of space here. 16y squared. So here, let me rewrite that. Okay, so I just rewrote that here for us. Okay, just rewrote that a little bit clearer. So that was the difference of the cubes, but now you don't want to forget there was that 2 out front here. So you have to include that in your final answer. And this is my result. That's it. We're done. Okay, so we just completed this by using the difference of cubes, but we first took out the GCF. Guys, don't forget to go back and do those colored problems that were done in pink. 6, 7, and 10 on this page, as well as the others that I highlighted. Alrighty.